Here I'd like to tackle problem 16D, and it looks like a pretty crazy formula. There's some copper, arsenic, oxygen, carbon, hydrogen in here, and it's pretty massive. So let's go ahead and calculate this. So we want to know the number of moles of compound and the number of moles of each type of atom. Okay, so we need to first start out by calculating the formula weight of the huge whole molecule. So to do that, we need to multiply the subscript of each element by the average atomic mass found on the periodic table. I'm using ptable.com as a source of my average atomic weights. So 4 coppers is 254.18. Now for arsenic, there's a subscript of 1, which is not shown, but there's a 2 here outside the parenthesis. So 1 times 2 is 2, so there's 2 arsenics in this formula. And arsenic is element number 33 on the periodic table. Okay. And next we have oxygen. Now for oxygen, I'm going to combine these different numbers. There's 3 oxygens here with a 2 outside the parenthesis. So 3 times 2 is 6. And then there's a oxygen here in the formula. It says O with a 2, and then there's a 2 outside the parenthesis. So 2 times 2 is 4. So we have a total of 10 oxygens. So the number on our periodic table is 15.999, so that comes out to be 159.99. Next, we want to compute the contribution for carbon. That's our next element up. There's a 1 here not shown as a subscript for the carbon. There's also a carbon here. There's a 1 here that's not shown for a carbon. So there's 2 C's in the parenthesis. Okay, and there's a 2 outside the parenthesis, so we multiply that by 2 to give us 4 carbons in the formula. Okay, so it's pretty tricky to add those up. You could do it separately, but I just like to keep things as few steps as possible. So carbon, 4 times 12.011, 48.044. The last element that we have to deal with is hydrogen. Now there's a 3 here, and there's a 2 outside the parenthesis. So there are a total of 6 hydrogens in this formula. So that gets you 6.048. Now we want to add all of these numbers up, and that grand total will be the formula weight of our substance. Okay, and I get 618.106, and the units there are grams per mole. Now for step 2 in this problem, I want to calculate the moles of the compound. And I'm just going to call the compound CMPD for short, because the chemical formula is just so long to have to write. So what do we have? We have kilograms. I'm going to have to convert that to grams, and then I'm going to have to convert that to moles. So I have 0.125 kilograms. There are 1,000 grams in 1 kilogram. Okay. And then I want to use this as a conversion factor, but flip it upside down. So I want 1 mole of my compound over 618.106 grams of the compound. Okay? So the grams of the compound will cancel and I'll be left with moles of compound. So punch all that into your calculator and I get 0.202 moles of the compound. And you can rewrite the whole thing if you want this to be, nice in your final answer. Okay, so 0.202. Now to calculate the moles of each type of atom, we'll do that on the next page, and we use the chemical formula once again. So we know we have 0.202 moles of this, and there are 4 coppers in that formula. So 1 mole of the compound is equal to 4 moles of the copper, because there's a 4 in the formula. So we can convert moles of compound to moles of copper using this equivalency to create a conversion factor. So we want 4 moles of copper to be on top, and we want 1 mole of compound to be on the bottom. And basically what we're doing is multiplying that number by 4, because there's 4 times as many coppers in that as the whole unit, the whole formula unit. So 0.202 times 4 is going to be 0.808. And that's going to be moles of copper. Okay? And we keep repeating this procedure for the different elements. Now, 1 mole of the compound, as we discussed previously, has 2 moles of arsenic. And so we would set up the conversion like this. 2 moles of arsenic over 1 mole of the compound. Moles of compound cancels, and we're left with 0.404 moles of arsenic. So this is how you do the mole to mole conversions. Now for oxygen, we said there were 10. Let me see, switch to this color maybe. So we said that 1 mole of a compound has 10 moles of oxygen. And so we could set this up like so. (10 moles of oxygen over 1 mole of compound, and that's going to be 2.02 moles of oxygen. Carbon, we said there were 4 moles of carbon in the formula. C is carbon. So we set up the conversion just like previously, but this time we're going to multiply by 4 moles of carbon over 1 mole of compound. And we're going to get the same number as with copper, but it's important to write units. Very carefully write moles, and very carefully write the element symbol or the formula of the substance you're talking about. And the last one we want to do here is hydrogen. I believe we said there's 6 moles of hydrogen. So 1 mole of the compound contains 6 moles of hydrogen. So 0.202 moles of the compound times 6 moles of H over 1 mole of the compound is going to be equal to, and I'll do this on my calculator, 1.212, but you want to round this up to 3/6, 1.21 moles of hydrogen. Okay, so pretty crazy looking formula there, but that's how you calculate the moles of the compound and moles of copper, arsenic, oxygen, carbon, and hydrogen. So thanks for watching, and please subscribe.